Welcome to today's webinar, modeling around imported 3D CAD data in Shaper 3D. A little bit about myself. My name is Claas Kuhnen. I'm an industrial designer in Detroit, Michigan, USA, and I run the interior design area at Wayne State University and also teach there the industrial design courses. So with all that said, let's get started. So today's focus of the webinar will be based on how do we work with external CAD data. This could be something we built in Shaper previously, or also just any other type of CAD information or 3D model we could bring in. For today's exercise or demonstration, we will use a furniture piece. And as you can see here on the screen, they're all the individual building parts. For example, a drawer and a leg and a nightstand box, which were all pre-built in Shaper, and then also all the hardware. I also personally work a lot in furniture design. So hardware which we can buy, obviously you don't design, you just buy it. And I'm going to show you today the whole process, how we can save files in Shaper as external and bring them back into a new file, and then how do we source all these individual CAD files, because that is actually pretty amazingly easy. As a quick peek, for this we will use the free iOS app McMaster-CARR. They also have a website, so on the Mac PC you can do that too. And essentially that is it's kind of like Amazon for all the stuff you need related to hardware. So with all that set, let's start. How can we save a Shaper file as a new file, for those who do not know this, just as a quick refresh. So this is a very basic furniture piece. I put this into a folder called box. There are all the individual building elements, and as you can see here, I also have some wooden dowels measured. To save this now as a Shaper design, I see you just clicked on the export button. Then you go to Shaper, select that as a file. You can give this a name. For example, call this alone. Click continue. Share. Either we send it to somebody or an app, or you just go to save it locally. So I will save this inside the iCloud drive. Let me scroll down to Shaper 3D. There is the webinar folder. So in there, then this file I could save when I hit save. And that is essentially how then all these individual files you can create. Now, why is this actually useful? Well, when, for example, you have an element you would like to reuse in new designs, that's then the way how you can create that file as a standalone file and then be included into a new file. So how do you import it? When we are on the screen, you could either select new or import. I will actually just click new, and then I will show you how we import the Shaper file. So click the import button, then files. I will go to the webinar. And here is the nightstand box. So you can see all the stuff is being transferred over. Now I would like to bring in also my drawer. There's the drawer. Perfectly fits in. Well, it fits in perfectly there because in the first place I modeled it also in place. So that's maybe also another thing that's very important for you to understand. The way how something is modeled in Shaper, when you save it as a Shaper file and then you import it into a new Shaper design, everything remains exactly where it was initially built. So now I bring in the leg, and you see here the leg is actually built down there. So one of the big task you have to do once you brought in these parts, and let's say we want to create a new design, or in this case everything so far was a conceptual model, and now I would like to create the CAD data so that everything at the end will actually look like this. So there you can see there all the individual parts positioned, everything is adjusted correctly so that it is ready to be sent either to a craftsman or a CNC machine to be milled. Because in the design process you have an ideation phase where you create kind of like maybe sometimes messy, dirty geometry, and then you clean it up and create a construction or assembly design. So here in this case now, to show you also what I have and the steps you need to take, I have a construction plane here, and I simply use this construction plane to perfectly snap to there and then create right along that leg a cut section, so I can show you before we continue what's actually all inside this design. So I have here my wooden doll representations. They're very useful for understanding where everything will go to. I have the wooden leg part, the cap, as well as, for example, the socket geometry. Okay, so my task now is, with having this imported, I would like to position this one right under the nightstand. Looking from below, you can also see that the leg is nicely oriented along the x-axis, but everything has to be rotated 45 degrees. So I will show you now in this next step how we try to perfectly position this piece so that during the manufacturing part or prototyping, making part, dimensions and positions are very clear, easy to read, to remember, and to communicate. Before I continue, let me zoom in here a little bit. I go back to the lag group. By the way, for those who are not very familiar with using groups, as you can see, they are incredibly useful to structure your design. So here I have a representation of the socket outer diameter, and also a drawing to where the pins are. And everything is designed by using, since we are in inches, using very easy to read and to measure dimensions. So these are all 3/4 inch distances, which makes it very easy to specify and measure on the actual piece of lumber when I have to build this part. Okay, so let's show all this. And under this box, now I would like to precisely position this leg 45 degree. And before I continue, I have to help myself a little bit and sketch a small alignment helper. So I select this face with the pencil, with the finger, and double tap down at the bottom, and you see actually there is right at the X and Y there is a small center point. So I can draw a line right to the center point, and then this other point I reposition and snap to that corner. I would like to turn off the geometry to show you what happened. You see it actually created a small sketch right on that face. So it's perfectly lined up. And because this is a very even box, so 15 inches, this line is also 45 degree. With this line now, I'm going to go back to this part. I can now go to the lag folder, okay, then I will go to transform, rotate and move, and then I will select my geometry and also the dowel pins. That's very important. And with the pencil then click on that rotate tool, rotate it 45 degree. Very good. I will hide the geometry so it does not overlap with the sketch and the construction plane. Now I can redo the same. I will select the line, these circles, there, construction plane. Make sure, however, now that this is also right there where it has to rotate around the center, and rotate everything 45 degrees. Let's double check. Okay, alignment is perfect. Very good. So with this now set up, I can use the translate tool to move everything to a particular position. Seen from the top, you see that I rotated everything correctly to 45 degree. And on the next step, I can select my geometry. Very good. Including the pins. Click next. And here's the trick now. Somewhere here, I click and drag right to this endpoint. Then I zoom in here. And this I will snap to this line, which I also rotated, and I will snap to the endpoint of that line. Let's zoom in a little bit more to verify this is correct. Very good. And click done. So just the geometry I moved to there. If you want to move the construction plane or the rest too, then you have to select those in addition. But you see that this was very, very helpful now to move actually everything right to that part. Now, another small reason why this helper line will be very, very useful is I have now to move, when I go to the bottom view, move this like 45 degrees to the center. So I can go transform, move and rotate. I will select my geometry and check out what happens to the 3D widget when I move and snap it to this 45 degree line. You see how it rotates? Now I know that the first cut is actually 0.75 inches away from the edge of the ring. So I can move this maybe by like 2 inches or 1.75 inches. So also here I go in very easy to measure steps, and everything now is perfectly positioned. And the reason why I follow these specific steps is simply that then measuring where the hole has to be in relationship to the end of this corner point, it's very easy to measure with a ruler if we do a prototype. If we do everything with a CNC, then it's less of an issue. Okay, good. Then a quick demo about how can we speed up our work now a little bit. Since we have one leg positioned, we don't have to copy and rotate into the other 3 corners. So I will do the following. So I will clean up my design a little bit. This I don't need anymore, so for visual clarity I will remove it. Also here, this and this I will remove, so I only have the leg. And right on the ground I will draw 2 lines. These lines will be useful for mirroring, and you see just in a second why. So there's my box. Again, everything is perfectly modeled, being centered to the world. So my box is really centered inside the world. So now when I can use these 2 lines I created for mirroring, my legs always will be perfectly positioned. So I go to transform and mirror. I can select the leg group, click next, copy is activated, click this line, click done. Cool. One more time. Click the leg group, next, select the other line, have copy turned on, done. Awesome. See, super fast. A little bit of pre-planning and understanding how can you position everything really is very beneficial, because as you can see, then you can accelerate the population of a design or your design process in general really fast. So even tedious tasks can actually only take then a fraction of the time. So the legs positioned. Let's continue this part. At one point, I want now to create this piece of wood inside the wood shop. I want to be able to drill the holes into there, or by hand, or if I put this on the CNC, I want the CNC machine just to drill the holes for me. This is the reason also why I have these wooden dowels in there. So the dowels, and the way how I model them, first help me to understand what's the height. So the height, you see I selected these two faces, tell me that this red part that sticks out is ½ inch in distance. This is good to know, because when I select this face and this face, it tells me that this is actually 0.7. So I have actually 0.2 inches of material left. So that means the dowels are perfectly inside and not too close to the edge of this wooden board. To create the holes, now I can go to Tools, click Subtract, select the leg folder, or if I want to be sure, I could also open this folder first, click Subtract, this bottom part, next, and now I select just the folder with the dowel pins inside. You want to turn on Keep Original, because otherwise the dowels will be gone. Click Done. Now I will turn the leg off, rotate my view, and you see there are the holes all cut at once for you. Very good. Okay, so we would like to build this piece completely. And now it's time actually to take a look at McMaster. This was actually an intro furniture design piece for my students. They needed to learn how to design this in Shaper and then buy the lumber, map everything out. We pre-cut everything, and then on a table saw we cut the individual building parts to the distance they needed. We also did the miter cuts on the table saw. But for example, this wooden plate here is just loose, and we have the dowels in there. And here this is also loose, and this has no dowels in it. So how do we make sure that everything stays together without using wood glue? Now you could use wood glue, but then it's glued together. And the idea was just to get the students learning the different tools. So let's go to McMaster. So we need a bracket. This app, again, as I mentioned before, is actually free. You can download it. It's also available via the web for every other system. I always call them Amazon for hardware. We go to search, and we type in bracket, because that is essentially what we need. Tab bracket, general purpose brackets, and look at that, corner reinforced bracket. So that's a good one. Let me explain a little bit what you see here for those who are not very familiar. This might be a little bit intimidating with all that information, but it's actually very easy to read, and it is super organized. So in upper left corner, you see corner reinforced brackets, the text, and then below is a graphic. It says CBAA. And then if you go to a little bit lower, you have the spreadsheet, and that tells you that for A, that distance is 2 inches. And then B, that's the base. C is actually 5/8 of an inch. It tells you then also the number of holes, and what's also pretty cool, the number of the screw size, number 8. Okay, And below then we have 3 inches, 4 inches. 2 inches is good. That's the one I want. So tap on the blue text. And then it will open the detail part. Now we have all this specific explanation, what material it is, technical drawing. So you don't want to go to Shaper and model this, because we can actually get this CAD data and transfer it right into our design. To do this, upper left corner you see again the name, inside corner reinforced bracket, then the share button, and then this bullseye and CAD. So click on this CAD, and that then pops up the menu of we can export 2D drawings, 2D PDF, but also 3D step. That's the one we want, 3D step. Now again, we could save it to a file. That is essentially what I did here. So I have all these parts which I'm going to use saved, including also that PDF for future references. But what we want is to directly insert this right into Shaper. So at the app section, I slide to the left and select copy to Shaper. And I will ask you, do you want to include it into this design or make a new design? Obviously, we want to include it. So new design. Include into current design. Very good. So this bracket we would like to put into that corner. There are 2 ways how we could do this. We would go ahead, and this has to be rotated 90 degree, 180, and this has to go up. And then we have to move it to there. Let's go to the front view. Then we can zoom in. And then by more zooming in, trying to precisely position it. Now keep in mind, everything in CAD is super cut, super precise. In reality, surfaces aren't as that straight. So if we want, in terms of, since we're working in furniture, we could just try to very carefully position this. I move this widget a little bit closer so I can zoom in more and just fine tune this position. So that, for example, is pretty close. But if you want to be very precise, let's say it's also a mechanical part, that we don't have the luxury of being a little bit more loose, I will show you this approach. Tricky thing is, I have these 2 rounded edges and I have nothing in between, so there's something I could really snap to. But we can actually create a snap target for the translate command. So I selected this face with my finger, double tap. Oops, okay, that means this one is in my view. So let me hide this for the moment. Very good. And I will go ahead and say Tools, Project, this and this, next, onto this face, done. If I rotate my view, there we can see we have projected these faces into rectangles. Well, this is very useful because what I can do now, there you see I have some stuff I can snap to. So I will draw a line connected there and a line to there. Very good. So there where these 2 lines meet, that is essentially kind of like the corner I need for snapping. Cool. Okay, so with this target created, let's turn on box. I can now go ahead and say transform, translate, select this part, next. I will actually do it this way. So I say U to there. I will zoom in and make sure this is really inside that corner. It is. And now this white dot I need to reposition. and say this dot should be right there. Cool. Click done, and there it is. Very nice. Let me just redo this because I just want to only make a copy of it. There. Very good. And bring this to the to there. So you see, be careful with the way how you move the pencil. You could sometimes snap to a different snapping target. Okay, good. To bring this over to the other side, this is very easy. I just go to front. If everything is modeled cleanly, there, I draw myself a line. Then I will go to transform, mirror, select the object, select the line, copy, and there it is. Cool. Now, I will actually remove this in first part there, and also remove these sketches, which were helpers, just so I can clean my design a little bit. I would like to get this to the other side, so the other top corner. To do this, ideally, what I want to do is essentially this. So this face I can select, double tap, and via project, I could project these two lines there, next, onto this face. Done. Very good. The sketch I will move out of this group, so it's on top. So I can hide now actually the box. Okay. There you see now I have the top and the bottom line. I will select this face just to make sure one more time. Then I'm actually on the same plane. Good. And now I will draw a line here in between there. Then I find the midpoint. There is this midpoint. From the midpoint I draw another horizontal line, and this is now my next mirroring line. So you there, bring this over, done. Cool. And then the sketch can go. I don't need it anymore. So, and essentially, as you see, this way very quickly I imported a bracket, positioned it, and then used the symmetry and the mirror command to populate all the individual corners. Before we continue to the next element, let's take a look at the screws actually. So they said this will use the screw size number 8. Let's look at screws. There are screws, and you can just see they have quite a different set of different types, also different materials. So let's say we go wood screw. There are wood screws. So you can be very specific. So flathead screws for wood, okay, select that one. Number 8, that is what was specified. So we can even select this material. We say, yeah, steel is fine. And then the length. Now our board is 0.7 inches. So half an inch. 5/8 is already getting close, 3/4 now, so half an inch. There's actually now the selection of the different type of screws I can get. These images I have there right now, they're a little bit misleading. So click on this, let's select that one. Now scroll down there, you can see how small actually that screw is. Okay, now here we do the same. Bring the screw over. And then I will also tell you why we are doing it this way. So save to files. There. Oops, not save to files, sorry. Send to Shaper and into the current design. Very good. So positioning this screw actually will be a lot easier now. So I will move this one up. I will start with this one corner. I would like this to be there. Okay, very good. And I will hide all the other stuff I don't need. So now we'll go to translate. With the pencil, so double tap, so the object is selected. Next, click and drag. So here's the nice thing. So this is a circle, which means I can snap from any edge or on the face, or if I'm careful, from the center of the arc. And then reposition this to the center of the arc. Click done. There it is. So the screw, as you can see, sits somewhat inside. The way how Shaper offers section views is really great. I select this face, double tap, with the fingernail turn on the section view. Then I can double tap and select the whole screw and just move it slowly back till I see a gap coming. So there it is. Okay, good. So now I can zoom in a little bit. Now another thing, let's zoom in here. You say, wow, this is really big. In CAD this might look like. In real life I select this and this is just 0.047 inches apart, so it's actually not that big. And we need that little bit of helper there. The reason why it's good to bring in these screws, if you want to, for example, use them. Now I can also think about what type of drill or hole do I need to create. If I select this, for example, as a 0.055 diameter for the hole, and then the threading can basically cut into the lumber and secure the screw. A little tip here before we continue. Also good to always have, I took a screenshot here, to have drill bits handy so you could see what type of hole, for example, can we cut. I could create such a hole by hand via the drill. I mean, these holes are really tiny, so I should do this by hand, or I could also use a CNC and just via the CNC precision put in all these holes, so I don't have to do this by hand. To create the hole, for example, for 0.055, we will do this. I will click on this face, the screw is hidden, double tap. See, then this lines up the sketch grid right onto that face. I have there the snapping center of that circle for the hole, so I can with the pencil make a circular motion, bring this over, and then dot 0.055. Okay, so there's the radius, and then select this, extrude this out a little bit. Now I don't know how long does this have to be, so I can make this a little bit longer. Okay, there's imported screw, and again this whole piece is actually running through the lumber, so this cannot exceed 0.75 inches. Then it will penetrate and cut through. I also don't need to make this as long as is. I can make this a little bit shorter, maybe just 0.24, 0.25 inches, and then the rest of the screw, the tip, will start eating into it. Very good. So the screw, as you can see in this case, was more a little bit of a helper, and now I can go ahead, again use my translate command with the copy, and then say from the center to the center. Yes, there it is. There it is. We have to rotate those. Make a copy. You see I clicked on this plus icon, rotate 90 degrees. Deactivate the copy. If you then want to position them by hand, translate there. All actually can go to there. Very good. And then this one here I bring over, okay, and just will fine tune the position. Let's see. There to okay, good. There was a little bit of an interface overlay. There, cool. Now, pretty easy, as you see. So, and again, the reason why I'm creating these cylinders is they essentially function as a hole tool. I could either project those onto a sketch, or I can, when I bring back my box, go tools, and then subtract and say U and U minus these holes. Click done. See, I also again here keep my hole. Let's clean all this up. So brought all the hole icons or elements into one folder. Would like to clean up and organize this and call this hole cuts. There. Hide this part. There you see that. And these holes can later still be manipulated. We can adjust also the radius as needed. We can move those around, and if we don't want those, we can even delete these holes. So that's a pretty great direct modeling capability of Shaper here. Okay, so you can see that essentially it makes sense to do all this work on one corner, because the other three corners are exactly the same. And then we just bring these all over. The screws are not necessarily important to be positioned onto each part for rendering. If you want to create a nice rendering, then yes, maybe. But for the manufacturing part, the screw essentially will help me here to understand the dimension of the screw I might put in. And that essentially is it. And then I can just count. Each bracket here has 6 holes. I have 4 brackets, so 6 plus 6 plus 6 plus 6, 24 screws is what I need for the bill of materials later. Very good. Another, again, repetition. Clean up your design, organize everything. We call this now corner, or actually we call this bracket corner, because it is a bracket. And then what type, because you might have different brackets, angle bracket or so. Good. And this was the screw. Oops. Screw number 8. Very good. So let's take a look at a more complex element to include. These drawers, glides. Again, now you don't need to model these. They are all actually pre-made. You can buy those in the stores. And then here you have the CAD data, including all the holes actually they have, so you can perfectly pre-plan your design, position all the elements where you need them, virtually prototype, and then create the holes and manufacture your piece. So how do we bring this one in there? Let's go to here. Very good. Now that's the one we need. Then type in glides. There, draw glides. There are quite a lot of different types, quality, how far they extend. Do they work via gravity? Do they have a hold open drawer or push open? Do they close on their own? I used here in this case the 3/4 partial drawer, so that the nightstand is not going to tip over because when the drawer is out too far and you have heavy books in it, it might flip. So here again we have also different lengths. This is very, very helpful. So essentially, before you start designing a furniture piece, let's say here with a nightstand, you want to use glides, you want to make sure that you model it around the hardware you can buy. So we have 12, 14, 16. So if your drawer is 10 inches in depth, then you're out of luck. Or at least on this website, they do not offer a 10-inch one. So here we select this one. Also, this one has the number 8 screw too. Now again, there's a CAD file that gives you all the dimensions, etc. And here's our 3D CAD file. Let's bring this one over and into the current design. Very good. Okay, so this now I will call actually glide. There, very good. I need to rotate this one. So rotate this one 90 degrees and 90 degrees. Very good. There. And we have now to position kind of like this corner at this corner. Again, we can do this very easily via translate. I select the glide group. Next. And just do preemptively putting some targets down there. There we are. That's this edge. And this one will go to there. Next. So now I have, as you can see, that perfectly lined up. That is good. Selecting the group, go to front. I can go ahead and bring this whole object down. Let's say position my snapping target to there. Okay, so this is super close. Very good. I deselect everything. I go one more time, select it, and I could bring this up, for example, 1/2 inch or something like this, wherever you want to have this part done. Before I continue, I have now to bring in the drawer. So here is my drawer. Very good. And oh shoot, it all overlaps. What do I do? This is not good. Okay, so no problem. First, the box we hide. The glide looks like I have to move back by how much? This is 0.7 inches, so I select the glide, move this back by 0.7 inches, negative. Okay, one more time. There. Good, so that is done. But oh dear, my drawer does not work well with the hardware. Okay, not a big issue. So this whole object here, how much do I have to bring it back to the other side? Well, let's take a look what we have here. It tells us this whole object is 3/8 of an inch thick. Okay, this might be a nice moment to also show you. Then when we work with units, we can work with decimal or fractional. Okay, So this whole object I want to bring over 3/8 of an inch. There, very good. Could also tap it and then type everything in this way. Very good. Cool. Let's do the same here too. So we are consistent there, 3/8, and this one here I will bring back 5/8, maybe 3/4. Very good. So that means also then this and this face I need to move back 3/8. Very good. This face I would like to line up with this face. How do we do this? The translate tool is amazing for that. So I select this face. Good. So then you snap to there. So I snap this corner to that corner. Done. Zip. There you see it got adjusted. This object's a little bit too wide. Just as a little tip, well, we can use subtract and say u minus u, keep the tool, yes. For those who are not familiar with what this keep the tool means, I do not turn this on, so you see the tool's gone. Okay, so you, there, keep it, very good. And then this whole object has to be trimmed too. You see I used the Boolean modifiers a lot, or the solid tools for trimming parts. Very good. Okay. So my drawer glide is actually extended by 9 inches. That is also what they tell. Here you see travel length 9 inches inside the diagram, which means if I go to the drawer and I will select this one. Oops, not drawer, I meant the glide. So here, this is extrude 3. I call this one now out. And I make a copy, turning on this icon, and just zip, bring this back to 9 inches. And then rename this one in. Okay, so the reason why I do this is actually, it first helps me to understand where to what degree stuff can extend. And this glide, I will actually, or this part of the glide, I will move into the drawer folder. The reason why is when I take the drawer, I know 9 inches. I can move this one out 9 inches. There. You see, I'm kind of like virtually prototyping the way how everything would operate. Okay, let's bring this back. Are we on time? Yeah, we're getting there. Very good. So number 8 for the screws, that was the same. So I can now decide how do I want to secure the 2 parts of a glide to the drawer and then to the box. If I zoom in a little bit, you see there are actually slots, not holes. So why are there slots, not holes? With a bracket needs to go into the corner and just securely hold everything. The glide obviously needs to securely hold the drawer, but lumber might warp during the summer, winter, moisture, or the ground is a little bit uneven. Nothing in real life is as precise as in CAD, so you need to have ways to adjust these hardware parts, let's say like here glide, around pre-drilled holes. And you do this via these slots. So I could move it a little bit forward, backwards, the top up, the top down, the back up, the back down. So I will make a decision to create a hole here and nice in the back around, let's say, this one. So to do this, there again, I can select this, make a copy, move this up, very good, turn copy mode off. There, make a copy, bring this over. Very good. Now we'll select translate. U. So from the center to there. So this is the arc center, but because we have a flat line there, this is a little bit more tricky. Here again, then we can select this face, double tap, and we simply will then create a geometry helper. There I have 2 midpoints. And the same here. Whoops, careful how you draw it. There. Okay, so these lines now I can use to snap to. Okay. See, it snaps actually to the line midpoint, and then I only need this one to there. Done. Let's see. Yeah, perfectly centered. Let's do this one more time with this one here. Bring this over, drag this out a little bit. And snap to the midpoint. You saw that actually how it's set midpoint. One more time. There. There also, while not even looking, rotating at it, it snapped actually to the central point. Done. Very good. You would do this also on the other side. And where did I actually model these parts into? Let's see. So these cut holes are there. So if I want now, I can select, where are they? These two, okay. I have selected and I put them into maybe a new folder there. So it's easy to separate them. And I call those glide. There, very good. And this folder I bring into this cut holes folder. So, and I make one more folder. This is just a suggestion, and I call this one bracket corner. Select all those and move them into this folder. So everything is nicely structured and organized. Let's go to the front and let's draw a line up, because we're just quickly pretending everything for the glide for the drawer is done. You see I just created my helper again, mirror, then I will select the glide, next, copy to the other side, very good. Now, because I put into the hole cuts folder 2 folders, I need to go to that folder first, and there, select those glides, next, there, cut, very good. And then let's turn on the box, tools, subtract. From this box, I would like to cut out the holes for the glides. Done. Very good. By accident, I removed them. So one more time. Could also select these 2 parts. You, turn this on. Done. Very good. And to show now how this worked, I turn all this stuff off. And there, see, there are the holes. Perfect. Yeah, and that essentially sums up the process how we can work around external CAD data, and that's either built, for example, inside Shaper previously and then saved into new files, so we can include them into a new assembly, or using McMaster and then sourcing here all the hardware we can find and including this then inside another shaper design. So this file here, I prepared this yesterday for those who are interested in, and this is actually a ready to manufacture nightstand. I will hand this out gladly for those who would like to make a piece on your own. It has everything actually inside. So the legs are there. The legs have also the dowels, and as you can see, all the holes are there. So what is white is actually 3D printed. Then we also have the box with all the individual parts. The holes are not cut yet. The drawer is adjusted so that actually there's a little bit of a gap, so it won't really rub onto the box geometry. The glides are put in. These are the same glides I used inside or for this demo, including then also all the holes. There you see they're actually for each side, so the box and the drawer, and then some of the screw placements. So we will share this with you if you want then to build your own nightstand. So, and that basically is everything I wanted to talk about. Do we have any question? Oh, good question. Step or IGES? Honestly, it doesn't really matter. From my experience, however, while they're both kind of like very similar, most people seem to prefer step compared to IGES, and I think sometimes that comes down to compatibility and also quality of the geometry or the data that's inside. And step seems to be a little bit more of a stable format, but essentially they're more or less the same with different flavors.